Okay, today we are going to be looking at section 11.5, which includes geometric probability and areas of sectors of circles. So the first thing that we're going to look at is geometric probability. And when we think about probability in terms of geometry, we are going to be looking at areas. So we are going to look at the area of the desired region or the region that you want, which will make more sense when we look at an example. The region that you want over the total area of the region or the shape that you are looking at. So let's do our example here first. So we're first going to find the area of the shaded region of the shape shown below, and then we're going to find the probability that a point chosen at random is in the shaded region. And we're going to round everything in this example to the nearest 100 because probability is typically rounded to the nearest 100th when we're discussing probability. So let's first look at how we're going to find the area of the shaded region. So in this picture, it looks like I have a semicircle and then a triangle within it. So in order to find the shaded region, we're going to take the area of the semicircle and we're going to subtract that area of the triangle within it. And that's going to give us the shaded areas region. So when I think about this area of a semicircle, well, area of a circle is pi r squared. And then it's only half, it's a semicircle, so then divided by 2. So when I look at this picture, the radius only goes from the center to the edge. So if the whole length is 50, then this length is just going to be 25. So the radius is 25. So I'm going to substitute that in. So pi 25 squared divided by 2. So if I take 25 squared and divide that by 2, that gives me 312.5 pi, which is the same as approximately 981.75 square centimeters. So that's the area of the semicircle. Now let's look at the area of this triangle. So this triangle, they do not tell me that it's an equilateral triangle or anything. So we're just going to use our regular area formula, which is 1/2 base times height. So when I look at this picture, the base of the whole triangle is 50, and the height of the triangle is the same as the radius. So we found the radius is 25. This is still going from the center up, so it's also going to be 25. So 1/2 50 times 25. So the area of this triangle is going to be 625 square centimeters. So now if I subtract that, if I subtract 981.75 minus 625, I get that the shaded area is 356.75 square centimeters. So that's my shaded, that is my shaded area, okay? So that's just one part of the question. So write that down somewhere. I'm going to erase this slide real quick so that way we can actually calculate the probability. Okay, so let's start just to get more room here. So the area of the shaded region, I'll just write that up here, was 356.75 square centimeters. So when we're looking at the probability, it's the area of the region that we want, which in this case is the shaded region, over the total area of the shape, which the total shape is this bigger semicircle, and we already found its area too. Okay, so area of the region we want, 356.75 square centimeters over the area of the entire shape, which is just the semicircle, which we found was 981.75 square centimeters. Notice that the units simplify off and probability doesn't really have a unit to it. So 356.75 divided by 981.75 rounded to the nearest hundredth is 0.36. So what that means is that if I were to choose an area at random on this entire shape, it has a 0.36 chance, or a 36% chance, that that point would lie in the shaded region. And so that's what you're doing when you're calculating geometric probability. Let's do another one. So we're going to find, again, the area of the shaded region, then the probability that a point chosen at random is in the shaded region. In this case, we're going to be taking the area of the bigger shape, which is a rectangle, minus the area of the circle. Okay, so area of a rectangle is length times width. So that's going to be 8 times 4. So the area of this rectangle is 32 square meters. Area of a regular circle, pi r squared. So the radius goes from the center to the edge of the circle. So if this whole thing is 4, the whole way across would be 4. The radius would be half of that. So the radius is just going to be 2 meters. So 2 squared. So that would be 4 pi, and 4 pi is 12.56 square meters. So again, we're going to subtract this to get the shaded area. And so the area of the shaded part is 19.44 square meters. So that's my shaded area. I'm going to write that up here so that we can then calculate the geometric probability. Okay, so let me clear everything. Keep that 19.44 up here. So then probability, area of the region we want, which is the shaded region, 19.44 square meters, over the overall shape, and the bigger shape in this case we said was the rectangle, and that had an area of 32 square meters. Units simplify, 19.44 divided by 32 gives me a probability of 61.61. So 61% chance that a point chosen at random in this shape would lie in the shaded region, which should make sense. This would be like 4, so it should be a little over half that it is going to lie in that shaded region. Okay? The other part of section 11.5 is area of a sector of a circle. So a sector of a circle is like the green highlighted region that you're seeing on this figure here, or you can think of it as like a slice of pizza. So it's not the whole circle and it's not a semicircle, it's just part of a circle. So the sector of a circle has an area of a square units, a central angle measuring n degrees. So this is an angle formed in the center of the circle, and that's going to help you calculate the area. And then, of course, a radius of r. So area of a sector is that central angle, n degrees, divided by 360 times pi r squared. And it's divided by 360 because there are 360 total degrees in a circle. So you're taking basically a fraction of the circle and multiplying it by the area of a circle. That's how you find the area of just a section or a sector of a circle. So let's look at a few examples. We're going to find the area of this sector found on this figure. In this picture, 135 degrees, that's what we call our central angle, and 22, that's my R. So area of a sector of a circle is that central angle measure, and I'm just going to call it over 360 pi r squared. So we're just going to substitute in. So 135 divided by 360 pi 22 squared. And I would recommend maybe doing like this division first on your calculator, hitting enter, then multiplying by pi, and then multiplying by 22 squared, or you can just do all the numbers first. If I did all the numbers first, I get 181.5 pi, rounded to the nearest tenth would be 570.2 square inches. 570.2 square inches. Okay? And last one. So find the area of a sector with a central angle of 88 degrees and a diameter of 20.5, and we're going to round to the nearest tenth. So this one doesn't give me a picture, but we can still find the sector. So if the diameter is 20.5, that means that the radius is then half of that, which would be 10.25 millimeters. So that's what we're going to substitute in. Okay, so area of my sector is n divided by 360 pi r squared. So my central angle is 88 divided by 360 pi. The radius we said was going to be 10.25 squared. So 88 divided by 360, just type that all into your calculator. Rounded to the nearest tenth, 80.7 square millimeters for that area of that sector.